Hello everybody, this is Carbon Killed the Cat, and welcome to your first and only Lua 5.3 tutorial. So, this is kind of a standalone video that I'd say kind of half fits into the Lua 5.2 series. And what this video is going to be is it's just going to be going over all the changes that have been made between Lua 5.2 and Lua 5.3. So, since I'm using the Zero Brain IDE, all you really have to do to switch from Lua 5.2 to 5.3 is go to Project up here, down to Lua Interpreter, and then you'll have an option for things like Corona, Love. Then you'll get Lua alone, which is 5.1. Then there's Lua 5.2, and then you may see Lua 5.3. If you don't see it, then you'll have to re-download Zero Brain, because it means that there's been an update that added Lua 5.3 since you downloaded the program. So, worst case scenario, you'll have to re-download Zero Brain, just delete it from your computer and then download it from the website again. But if you downloaded it somewhat recently, then Lua 5.3 will already be there, and you can just switch to it with this option. So now you're on Lua 5.3, and you have all the changes that have been made. So the most significant one is that there's now a difference in the background of Lua between floating points and integers. And for the most part, this really doesn't make a difference in the just front-end Lua programming, but there are a few things you have to keep in mind. So we can show that there's a difference now by telling Lua to print 2 and 2.0. So if we switch back to Lua 5.2, just go in here, go back to Lua 5.2, and we run this, we just get 2 and 2 down here. However, when we go to Lua 5.3 and we run this, we get 2 and 2.0. So in the program now with Lua 5.3, this is being treated as an integer, and this is being treated as a floating point. So the thing I said in the first, or probably second, Lua 5.2 video, that Lua doesn't differentiate between integers and floating points, and that they're all just numbers, that's no longer true. If a number has a decimal point when you declare it, it'll be stored as a floating point, and if it doesn't, it'll be stored as an integer, and it can easily switch. So if we were to say x equals 2, and then we were to say x equals x over actually that wouldn't work, x equals x over 3, and then we print x. So you can see that when we declared x, it's an integer because we don't give it a decimal point after it. If we called it 2.0, then it would be a floating point, but as of now, it's just an integer. But then we divide it by 3, and 2 divided by 3 is 2/3, or 0.6 repeating. So that is obviously a floating point. So unlike C++, where this would, or really any other hard-typed language, where this would cause an error, in Lua, x is just converted from an integer to a floating point. So it doesn't cause any problems, and this is really the reason that let's just run this. This is really the reason that you really won't see much difference in your programs between integers and floating points. Really, the only difference you'll see on the front end is this thing where numbers will be printed out differently. But this difference between integers and floating points does give us a new operator. So let's go back to our division operator. If we were to print out 2 over 3, and we run it, obviously we get 0.666 repeating, or 0.67, or a bunch of 6 sevens, because computers can't store infinite decimals. So we get a decimal here. The result of 2 over 3 is a floating point, obviously, so the print function prints out a floating point. But if we just want to work with integers to save space, then there's now a special division operator that will return an integer rather than a floating point, and that is the double division sign, the comment in most other languages, but it means integer division in Lua. And now if we run this, we get 0. So you can see that it divided 2 and 3, and then it just truncated the decimals, which means cut it off. It doesn't round, keep that in mind. It just cuts the decimal off no matter what it is. So if we were to say 9 over 10, we still get 0. You can kind of think of this as just normally dividing the two numbers and then calling the floor function from the math library on it. That's not actually what happens, but you'll get the same result if you do that. So let's show an example where we would get something greater than 1. So if we do 11 over 10, we get 1, where 11 over 10 is actually 1.1. So that's really the difference with Lua now differentiating between integers and floating points. So now on to the next topic. So our next topic is deprecation. So you can see that in the cut I made a comment with all the functions that have been deprecated. So all of the bit32 library has been deprecated, and if you don't know what deprecated means, it still exists in Lua, but there's a good possibility that in the next version it won't exist. They'll just take it out of Lua completely, so it's now considered bad programming practice to use any of these functions. So like I was saying, the bit32 library has been completely removed. It's been replaced by the more conventional bitwise operators, which I'll go over in a minute. And then in the math library, several functions have been removed. The atan2 function, hyperbolic cosine, hyperbolic sine, hyperbolic tangent, the power, so a to the x, or a to the b, fractional exponent, and LD exponent. So these have all been removed, and there are several reasons. For the atan2 function, the normal atan function now basically just works the same way as the atan2 function, because there really was no advantage of using atan over atan2 in any situation. So now the atan function takes 2 arguments rather than taking just a ratio as 1 argument. The hyperbolic functions, they can all be implemented just with your own functions. Power, there is actually an operator for exponents now, so we can say print 2 to the third, and that will print out 8.0. It's computed as a float, so 2 to the third is 8, and we get 8.0. So there is now an exponent operator, so obviously we don't need a function for that anymore, and these you can pretty easily implement by yourself. So all these functions have been removed, and they will be removed probably in the next version, and it's now considered bad programming practice to use them. And the reason they're being removed, rather than just having 2 possibilities for doing the same thing, is because Lua is meant to be a small language that's easy and not very space wasting to implement. So removing these functions in the end will decrease the size of Lua, so you can better include it in your applications without it taking too much hard drive space. So again, all these functions, you shouldn't use them anymore. And as for the bit32 library, so let's print. So instead of b and, we could say, we'll just use 2 bits, or not 2 bits, oxaf and oxfa. So 4 bytes here. The single and sign, single ampersand, that replaces b and, so if we run this we get 170, and actually let's do this. Print bit32, so this is showing that these functions do still exist, but you shouldn't use them. oxaf and oxfa. So I'm just showing that these are completely equivalent operations now. So we get 170 for both. B or is the pipe. Run this, we get 255. B XOR is the not sign. We get the same thing here. B not. If you remember, this only takes 1 argument, so it's slightly different. And this is also the not sign. So the little tilde gives us the same, or that does not give us the same thing. That is strange. Oh wait, actually, the reason for this difference is that the bit32, these functions operate on 32-bit data, and the binary operators, they operate on 64-bit data. So also I think that this is being assumed as unsigned and this is signed. So there are slight differences between the bit32 library and the binary operators, so make sure you know how these are actually working before you just assume that they will still be compatible if you just switch bit 32 to your binary operators. But for the most part, they are the same. This is just one example where they're different because we have 32 bits here and 64 here. The next thing we have is the shift left. So let's put this back here. So bit 32 dot L shift, and we have the normal conventional. That's not the left. Left shift operator, and we get 0 and 0. Then there is right shift, so R shift. Still get 0 and 0. Probably shouldn't be. This will probably be more exciting. There we go. And let's try that for left shift. I was shifting by quite a bit there. And we get 350 and 350. So we get the same thing. And the rotate operations, they're not very common operations. In fact, C++ doesn't even have operators for them. So they don't get operators in Lua, and since the bit 32 library is deprecated, you really shouldn't be using them. I've never seen them used before. I'm not actually sure what they're used for, but they're not necessary, so they've been effectively removed. They're still here, but again, for the last time, you shouldn't use them. So now the examples for the math library. So you can say math.atan. So you can see we still have atan2, but it's now, according to the Lua standard, bad practice to use it. So we say math.atan, and it now takes 2 parameters. So you can just give it 2 and 3, and we get 0.588, just a long decimal. So before, math.atan took 1 parameter, and we would give it like this, and now we just give it as 2 parameters. And if you don't know the reason for this, it makes the tangent function quadrant aware so that it can produce the proper answer in the first, second, third, and fourth quadrant on a graph, rather than only in the first. So it's far more useful, or it was far more useful to use atan2 than atan, but now it's all wrapped up into one function, so you really don't have to worry about it. And the rest of the math functions, besides pow, which you can now just use the exponentiate operator, to get the proper answer. Besides that, all the other math functions that are being deprecated, you just have to re-implement them yourself. Hyperbolic, cosine, sine, and tan, they all, or tangent, they all have, no, I wouldn't say simple, but they all have pretty easy to implement mathematical formulas. And then these are just algorithmic formulas that you can get pretty easily. I think even on the Lua reference it shows you how to implement your own function for them. But they're deprecated, so you do have to write your own function for them now. So that's all of the deprecations. And now we can move to the, in my opinion, more exciting part of the video, the functions that have been added. So the first function that's been added is called table.move, and this allows us to move elements from one table either into another table or also from a certain spot in one table to a different spot. So the function isn't very complicated, but it does have quite a few parameters, so I'll write out kind of a generalized syntax for it. So we can say table.move, and the first parameter is the first table, and then we give it the starting position that we want to start moving from in the first table. So we'll call this pt1, and then we want to have the number of indices in the table, or a number of elements in the table that we want to have moved. So number of elements. And then we have the position that we want these elements, or the starting position that we want these elements to be moved into in the second table, so p at table 2. And then as an optional parameter, so we'll surround it in square brackets to show that it's optional, which probably, that's better, we have t2. So this is how you would see it in the official Lua syntax. I actually have it up right here. This is it. So I changed it a little, but it's basically the same thing. So what this is saying is that when we're calling table.move, we have our first table, and then we're giving it the position that we want to start moving at, the number of elements in the first table we want to move, the position in the second table to start moving the elements from the first table into, and then as an optional parameter, another table to move the elements into. And if you don't give table.move this argument, it will just choose table1 as the table that you're moving the elements into, and it's just assumed that position at the pt2 argument will be different from the pt1 argument, so you're basically moving elements from one place in a table to a different place in the same table. So this will be easier to see with an example. So let's make our t1 and t2. T1 is 1, 2, 3. Let's do our classic simple example, and t2 will be 99, 98, and 97. So we'll call table.move and give it t1 as the first argument, and we'll start at position 1, move 2 elements, and start at position 2 in the second table, and our second table will be t2. And I'll show you an example without this argument afterwards. Now we just create a simple for loop. I is 1, go to 3, and print t1 at I, and t2 at I, and end. So if we run this, we get 1, 2, 3, and 99, 1, 2. So you can see that the first 2 elements from this table, because we told it to start moving in T1 at position 1 and to move 2 elements, so the first 2 positions in T1 were, it's called moved, but they were actually kind of copied into T2. So you can see that they haven't actually been moved out of T1, they were just copied and pasted into T2. So I'd call it table.copy if I were making the function, but moving is also a good description of it. So that's what it looks like when you have 2 separate tables. If we were to just call T1 as the last parameter, or just omit the parameter completely, then we would get 1, 1, 2, and then our T2 is unaffected. So the reason we get 1, 1, 2 is because we are starting the move at position 1, or we're taking elements starting at position 1. We're taking 2 elements, so we're taking element 1 and 2 from our T1 table, and then we're starting to paste the elements at position 2. So since there are 2 elements that we copied, there will be 2 elements that we're pasting. 2 elements that we're pasting, yeah. So it will start pasting here and finish here. So we copied 1, 2, so it'll paste 1 and 2. So we get 1, 1, 2 instead of 1, 2, 3. So that's the table.move function, and the other functions that were added are part of the string library, and they have to do with handling UTF8. So let's move on to that. So it turns out I was wrong. The UTF functions actually got their own library. So to access it, we just say UTF8 dot, and the first function is called UTF8.char. Oops. And what this function does is it takes some amount of numbers, it can be any amount, and it converts all those numbers into the character that they represent in UTF8. So we'll say 97, 98, 99, 100, and 101. So this should give us A, B, C, D, E. If we run this, that's what we get, A, B, C, D, E down here. 97 represents A, 98 is B, 99 is C, 100 is D, and 101 is E. All lowercase, obviously. So you could do this for any number in UTF-8, and all of the numbers that you give it after being converted to their representation in UTF-8 are concatenated together into one string. So this function returns one big string. So that's how that works. The next is not actually a function, it's a constant. It is called UTF-8 dot char pattern, and I'm not sure if this is actually going to print because it's a pattern that's supposed to be used in things like string.gsub and string.match. So if we run this, yet we get nothing, but I expected that to happen, so it is equivalent to this pattern in functions like string.gsub and gmatch. Actually, let's try, see if this makes any difference. It shouldn't, and yeah, it doesn't. So yeah, we can't directly print it out, but it is equivalent to this pattern, and what this pattern does is it matches exactly one UTF-8 byte sequence. So if you ever need to do that, this is just a shortcut for it, so you don't have to memorize this code. The next function is actually an iterator function like pairs, so we can say for PC in UTF8.codes of the string, we'll just do our example hello, and do, end. And what UTF8.codes will do, it returns two return values, obviously, for P and C. P is the position in the string, and C is the UTF-8 code. So if we print P comma C and run it, we get 1, 104, 2, 101, 3, 108, 4, 108, and 5, 111. And you can check that it all checks out. 104 is the code for H, 101, as we've already seen, is the code for E, 108 is L, and 111 is O. So the P is representing the position in bytes that each character starts being encoded at. So the H starts at byte 1, E is byte 2, L is 3 and 4, and O is 5. So if you had any character that took up more than one byte, I don't know if this IDE would accept any of those. It's like symbols, like the smiley face, boxes, anything like that that doesn't fit into, I think, 128-bit ASCII, maybe 256, I'm not sure. Anything beyond that will take up 2 bytes, so you would get like 1, then 3, 4, 5 if we had one of those. But I'm not, we can try actually. Alt, just for the fun of it. 289, and if we ran this, nope, we still get something. I think it actually overflowed there. Let's try something else. Alt 245. Put that in the wrong place. 245. Yeah, the Zero Brain's not letting me do it. I'm trying to just put in characters that are high up on the ASCII table to try to get something that would take up 2 bytes. 230, 212. Yeah, it's not letting me do anything. So yeah, we can't show any examples that take up 2 bytes, but if you did have a character that took up 2 bytes, it would show up in here as taking up 2 bytes. So you would get a skip in the P variable, and then you would just get that ASCII code in C, and it would be greater than 128. So that is UTF-8.codes. The next function is called UTF-8.codePoint. So we print this out. UTF-8.codePoint. It's not auto-completing it for me. And we give this function a string. And then as optional arguments, we give it 2 positions. We'll give it 2 and 4. So what UTF-8.codePoint does is, let's run it. We get 101, 108, and 108. So this gives you the UTF-8 codes of all of the characters in this subject string here between the starting position I and the ending position J. And by default, the starting position is 1 and the ending position is the same as the starting position. So you can see we started at position 2, so that is our E, and we got 108 here. And we ended at position 4, so we have 1 as H, 2 is E, 3 is L, and 4 is the second L. So we're going from the E to the second L, so we get ELL, 101, 108, 108. So we got those as the result of the function. They're returned as 3 separate numbers. We could change this to 5. We'd get 111 for O. Change it to 3. we just get 1L. We could start at position 3, go to position 5, and we get 108, 108, 111. And we could get rid of these parameters entirely and just get our H. We can only have one parameter, just get 101. So there's a lot of freedom you have. You can omit a bunch of parameters, and you can really go anywhere in the string and get the UTF-8 codes for all the characters in that range. The next function is very similar. It's called UTF-8.length, and you give it basically the same parameters, so we'll give it between 2 and 4 again, and it just gives you the length of that sequence in bytes. So this is 3 bytes. We go from 2 to 4, so ELL, that's 3 bytes. Go from 2 to 5, we get 4 bytes. Basically, it's just this number minus this number plus 1, unless you have a character in here that takes up more than 1 byte. But for normal words, that's pretty much the formula, so it's not a very exciting function unless you have a more complicated string that has bigger characters in it. So that's the UTF-8.length function. And finally, we have our last function. It's called UTF-8.offset, and it is, again, very similar to these last few functions. Sorry if you've been hearing construction sounds outside throughout this entire thing. There are people working on my neighbor's house. Sorry if that's been annoying. So UTF-8.offset, and this takes 3 parameters, just like the last two. The first is our subject string, and I probably shouldn't have deleted this entire line here before. And the second is our offset, and I'll go over what that means in a second. And the last is our starting position. Again, I'll go over what that means in a second. So if we run this, we get 4. And again, the results from this aren't going to be that exciting because there's really no way to have any more exciting strings here without making some more complicated code. But basically what this function does is it starts at the position you give it here. So we give it position 2, that's starting at E. And then it offsets from that position by the second parameter, so it goes from 2 and offsets 1, 2, 3, so it's at the second L right now, which is position 4 in the string, and then it returns that position. So for simple strings like this, again, not very useful. When you get to more complicated UTF strings with bigger characters and more complicated codes in it, then the function would get more useful, but we really can't show that in this right now, so just know that this is what it does. It starts at a position, and I guess you could think of it as starting right before that position, between the H and the E, and then it moves 3 positions and then returns that position. So starting at position 2, or right before position 2, it moves to position 3, or right before position 3, right before position 4, and then at position 4. So, and then it returns that. So that's UTF-8.offset, and that is all of the UTF-8 functions. And the final functions are in the string library. There's string.pack and string.unpack. But rather than go over them in this video, I'm going to save it for the next video, which will, even though I said that this would be the only Lua 5.3 video, I'm actually going to save it for the next video because the string.pack and unpack functions involve a format code, and the format string that you give to make that format code is approaching the level of complication of the string library format codes that created that, I think, hour-and-a-half video for the string library. So I'll save it for its own video. Here, I'll actually show you somewhere in here. Here it is. These are the format strings for string.pack and string.unpack. So I've got to look over this, plan out a tutorial for it. But as you can see, it is pretty complicated. In some ways, it actually looks a bit more complicated than the string library one up here. So I'll plan this out, and we'll have it in the next video. So I know I said in the last video that we'd be starting, or continuing from about a year ago now, the C library tutorials, but looking through what I had left, I still have some thinking to do on what I'm going to do with the C library videos. So in the next few days I'll have an announcement video about that, so look forward to that, and I'll see you in the next Lua 5.3 video.